for a number of years, boats, trains and factories were powered by engines designed by innovators such as James Watt and Richard Trevithick. But people wanted engines to be smaller in size, more powerful and more efficient. Eventually, a new type of engine was invented. It's called the internal combustion engine. The internal combustion engine is the type of engine we now use in most road vehicles. But what is combustion? Do you have any ideas what this could mean? Combustion is the scientific way of saying burning. In order for something to burn, we need three things. It's called the fire triangle. You might already know what these are. Have a look and see if you can figure out what the three elements are. Okay, so the first thing is oxygen. Fire usually gets the oxygen from the air around us. The second thing is heat, which often comes from a spark or even from another fire. And the third is fuel. Fuel comes in many different types, so we're going to look at some different fuels and see how they burn differently. Instead of burning wood, paper or other solid things like we might be used to, we're going to be burning some liquids. Here are some small containers that I'm going to fill with some mixtures. One by one, we add our chemicals. In the first one, I'm going to mix in sodium chloride, which is basically table salt. In the second one, I'm going to add some potassium chloride, which is used as a fertiliser and in medicine. And finally, in the third, I'm going to add lithium chloride, which is another type of salt. But don't try putting this on your fish and chips. Okay. So, I'm now using something called ethanol, which burns very easily and has very little visible flame. This is great because our chemicals will change the colour of the flames. These are our fuels. So, we have our three fuels, and there's oxygen in the air around us. This means the only thing missing from our fire is heat. So, using this splint, we can see what happens when the fire triangle is completed. Let's turn the lights off so that we can see the flame even better. Firstly, I'm going to light the sodium chloride. So, the ethanol is starting to burn, and that is the small blue flame we can see. But gradually, the sodium chloride also starts to burn, and we get a bright yellow flame. Eventually, all of that ethanol is burnt out and the flame will slowly start to die down. Next up, I'm going to light the potassium chloride. Again, at first we see a blue flame, and that's the ethanol combusting, or burning. But slowly, the potassium chloride will start to burn as well. This time, instead of the yellow flame like we saw with the sodium chloride, we get a purple flame. And finally, I'm going to light the lithium chloride. Have a look, see what colour you can see. As before, we start with the blue and yellow flame, which is the ethanol burning, but see if you can see the flickers of another colour starting to come through. That's right, lithium chloride burns with a bright red flame. Amazingly, different chemicals burn with different colours. The heat causes the chemical to react with the oxygen. The sodium chloride is much more yellow. The potassium chloride is more blue, and the lithium chloride, you can see, has red in the flame. Fantastic, now that the flames have extinguished, let's turn the lights back on. So, when we combine together our three things in our fire triangle, we get our fire: the oxygen, the heat, and the fuel. If these fires were bigger, we'd even be able to feel the heat. The internal combustion engine was a very important innovation because instead of using hot steam to power the engine, it simply uses the hot air created from combustion. Originally, it was hard to make it work using just the air around us, and some people's attempts were quite dangerous. But eventually, a man called Nikolaus Otto created an engine that could run successfully on petrol. This led to the invention of modern cars, which use internal combustion engines.